Rational expressions. So what is a rational expression? A rational expression is just the quotient or division of two polynomials. That's a rational expression. That's all it is. When you have a polynomial over a polynomial. Now, we're going to talk about how to simplify rational expressions. To simplify rational expressions, it is a very simple task. It is very simple if you know how to factor. Knowing how to factor is over 90% of the battle. If you know how to factor, then you should not have any problem whatsoever with simplifying rational expressions, because all you have to do to simplify a rational expression is to factor both top and bottom and then cancel any common factors. And that's all there is to that. So, for example, let's simplify all these three. Start with A. Simplify x squared minus 9 over x squared plus 4x plus 3. Okay, all we have to do is factor top and bottom and cancel any repeated factors. Um, anything that is, you cancel one from the top with one from the bottom. Okay, so the top is a difference of squares. So that is going to factor as x minus 3, x plus 3. And the bottom factors as x plus 3, x plus 1. Okay, once you have factored both, you are going to cancel um, common factors. So I'm going to cancel this x plus 3, which is repeated, 1 from the top with 1 from the bottom. And then once you cancel all the common factors, whatever remains is the answer. So this is going to be x minus 3 over x plus 1. Okay, and that's all. All right, let's simplify the next one. X to the 7 plus 2x to the 6 plus x to the 5, all that over x cubed times x plus 1 to the 8th. All right. Again, just factor the top and the bottom as much as possible. In this case, the bottom is already factored, so we don't have to do anything to the bottom. So let's factor the top. The top factors as well, you have to pull out the GCF first, which is x to the 5th. You see, x to the 5th is the GCF of the top, so pull that out, factor it out, and then you would get x squared plus 2x plus 1. All that, and then there's nothing to do to the bottom because it's already factored. Okay. Now we can keep going on the top. We can factor the top more. The top factors as x to the 5th, x plus 1, x plus 1. So x cubed, the bottom is x cubed, x plus 1 to the 8th. Alright, these x plus 1 and x plus 1 are the same factor, so we can simplify, write it a little bit simpler as x to the 5th, x plus 1 squared over x cubed, x plus 1 to the 8th. And now we're going to apply the laws of exponents to simplify these. So you can simplify, combine these and these because they're the same type of power. All right, so applying the laws of exponents, you subtract the exponents. So 5 minus 3 is 2. The fact that it's positive, that means it's on top, x squared. And then subtract these exponents, 2 minus 8, that's negative 6. The fact that it's negative means it's on bottom. So this is going to be x plus 1, 2 to 6. And that is the answer. Okay, now let's do the very last one. You should try the last one. Although the last one does require a little trick over there, but you can try. See if you can figure that out. Okay, the very last one has a little trick, as I said, but it's still the same idea. You factor top and bottom and cancel as much as you can. So the top is a difference of square, so it factors as x minus 5, x plus 5, and then the bottom, the x is common, so this factor is x, 5 minus x. And at this point, you're supposed to cancel any repeated factors. Now, um, here, you see these two are almost the same, but not quite. And so that means we cannot really cancel them. Because in order for us to cancel things, they have to be really identical. You cannot really cancel unless they are identical. And x minus 5 is not really identical to 5 minus x. If it was a plus in there instead of a minus, then it would be identical. Because x plus 5 really is the same as 5 plus x. For example, like 3 plus 5 really is the same thing as 5 plus 3. However, with a minus, that's not the case. 3 minus 5 is not the same as 5 minus 3. One is negative 2 and the other one is positive 2. So with a minus, it's not really the same. If it was a plus, they would be the same. Okay, so since they're not really the same, you cannot cancel them. However, if you were able to flip the order, right, switch the order, you could cancel them. And then what we do then, you can do that if you pull out a negative. So that's the little trick here. We're going to then pull out a negative from the top or from the bottom. It doesn't really matter. Let's say we do it from the top. It doesn't matter again from where you put a minus. Pull out a minus. So let's say I do it from the top. Then pulling out a minus is going to allow me to switch the order. That's going to allow me to reverse the order. All right, and the rest stays the same. Pull out a minus. If I were to distribute this minus, I would get negative 5 and positive x, which is what I have here. I have negative 5 and positive x. So, and now you can cancel. So this is gonna go. This is gonna go. That's gonna go. These are identical now, so I can cancel them. And then what remains is negative x plus 5 over x. Okay, so you can leave it like that. You can, if you want, you can distribute the minus over the top, and you can remove the parentheses. It would be minus x minus 5, or negative x negative 5. Or you can just write the minus right in front, and then you don't have to worry about the parentheses. But if you want to remove the parentheses, then you have to actually distribute it across the top. It would be negative 5, it would be negative x minus 5. So either way is acceptable. All right, and that's it. So now, so remember then that little trick over there that we had to employ. If you have two things that are almost identical with a minus, but the order is reversed, you factor out a negative. Factoring out a negative allows you to reverse the order, and then you can cancel. All right? Okay. That's how you simplify rational expressions.